Okay, we're going to go through our guided practice for converting fractions and decimals, and then you guys will finish up your assignments for the day. And so if you guys hear some crazy noises in the background, my dogs have randomly started to try and play around, so just ignore that. All right, so we're just going to go through a couple examples just like normal. So our first example is going to be 5/6, and we're going to convert that to a decimal, and we're going to see if it's terminating or repeating. So remember that top number goes inside the house, bottom number goes outside the house, and we're just going to use our decimal division to finish up. So 6 cannot go into 5. I'm going to put my placeholder, going to add my decimal and bring it up. And now I'm just going to go ahead and do my division. So 6 can go into 50 evenly 8 times. There is a decimal there. And then 8 times 6 gives me 48. And then I'm going to subtract and get 2 left over. I'm going to bring down a 0. 6 can go into 20 3 times evenly. I'm going to have 18 and a 2 left over. I'm going to bring down a 0 again. And hopefully we're starting to see that a pattern is emerging. And so that's going to keep happening over and over and over again. So I could bring down another 0, but I'm not going to because now I know this is going to repeat. And those are ... dots. I'm writing on my touch screen so they look a little bit messed up. So this 5/6 would give me a repeating decimal. We could also know that that was going to give us a repeating decimal because we have that 6 in our denominator, which was one of our unit fractions for a repeating decimal, and 6 can't go into 5 evenly, so we should already know that's going to be repeating, and then this would be the final decimal we get as our answer. Another example is going to be 7/2. Okay, and hopefully we notice that this 2 in the denominator, right, that can go into 10 evenly, and it can also go into 100 evenly. So that tells me it should give me a terminating decimal, but we're going to go ahead and do our division and figure out what our decimal would look like. So again, we're going to put top number in, bottom number out. You guys can probably hear my dogs in the background. 2 can go into 7 evenly 3 times, and we get 6 when we multiply. Now we're going to have to add our decimals because we had something left over. So we're going to bring a 0 down, and 2 can go into 10 5 times. So our final answer would be 3.5, and that would be terminating. So there's the difference is that if I have a base that can go into a 10 or 100 or 1,000 evenly, like 2 or 5 or 4 or 10 or 20, those can go in evenly. So those are going to give us a terminating decimal. But numbers like 6 and 3 and 9 can't go into 10 or 100 or 1,000 evenly. So that's why they give us those repeating decimals. So I'm going to go through one more example, and we're going to go ahead and be done. Running out of room a little bit down here, but that's okay. So I'm just going to show an example of why we need to know this information for what we're about to get into. So let's say that we had a problem that looked like 1/3 plus 0.1. Okay? So a lot of people like to convert them to decimals because they don't like dealing with fractions too much, but I can already tell from this denominator, it's going to give me a repeating decimal. And I can't just cut it off. I can't use that repeating decimal of 0.333 repeating as if it was 0.3. 0.3 as a fraction is 3/10, and those aren't the same thing. So I can't use this as a 0.3. And my directions don't tell me to round, right? So I have to use exact numbers. So in this case, I'm going to have to convert this guy to a fraction and solve. So that's when I would use, that's when I would have to do this decision making where do I need to convert them to both fractions or do I need to convert them to decimals? Well, this is going to give me a repeating decimal, so I'm going to have to convert them to fractions. So when I do that, remember over here, the way that I convert this guy to a fraction is it goes to the 10th place. So I would just put that decimal over 10. So that is what that looks like as a fraction. So my new problem becomes 1/3 plus 1/10. And so now I can just go ahead and make my common denominators, and then I can multiply by each other. So I could say the 3 times 10, so that would give me 10 over 30. And then I can say this times 3, so in the top and bottom, so that would give me 3 over 30. And then I would get 13 over 30 as my final answer. And so there you have it. That's why we need to be able to recognize those unit fractions that would give us repeating decimals, because it helps us make the decision of what's going to make the problem easier to solve and give us the exact answer. Because again, it didn't tell us to round, so we can't just change the decimal form of whatever that exact number is.